Okay, let's get into this. You've given us a whole load of material, articles, notes, research, all about blockchain. It seems to be everywhere. So today we're going to do a deep dive into your sources, try and cut through some of the, the hype and really get to the core of it.
Exactly. That's the plan. We want to pull out the main ideas, figure out why everyone's talking about it, and really understand why it's seen as so potentially revolutionary. The goal is for you to walk away feeling like you've got a solid handle on what this technology is all about.
Yeah, because let's be honest, most people have heard blockchain, probably think Bitcoin straight away, right?
Mm.
But what it actually is, how it works, that can feel a bit, fuzzy. And yet these sources, they really suggest it could fundamentally change how we handle information, how we establish trust online.
It's got huge potential implications.
So where do we start the story? The material traces it back to 2008, a paper by Satoshi Nakamoto.
That's right, yeah. Satoshi Nakamoto, which we know is a pseudonym. The initial idea, it was actually quite specific. It was built to support Bitcoin, the digital currency.
Yeah.
The challenge was, how do you create a trustworthy record of who owns what and who paid who without a bank in the middle?
Right, without that central authority saying, yes, this transaction is valid.
Exactly. It was about enabling trust directly between the people involved, peer-to-peer.
But it didn't stay just about Bitcoin, did it? Looking through this over the last, 10, 15 years, its uses have just ballooned. We're seeing it pop up in discussions about medical records, supply chains, even things like passport processing.
Absolutely. And the key benefit that keeps coming up, especially for businesses and organizations, is efficiency. Think about it. If you have one shared, reliable record, you cut out so much duplication of effort. No more reconciling different versions of the truth held in different places.
Less paperwork, less back and forth.
Definitely. And it reduces the need for those intermediaries, the brokers, the escrow services, whatever, that often add cost and complexity just to build trust between parties.
Okay, let's simplify. If you had to give a really basic definition, what is a blockchain? Forget the buzzwords for a sec.
At its heart, it's really just a digital ledger, a shared record book. But the key things are, it's immutable, meaning you can't easily change past entries, and it's distributed across a network. It records transactions, tracks assets, and assets can be, almost anything of value. Tangible things like property or intangible things like, say, intellectual property rights or even your digital identity.
Okay, immutable, distributed, so unchangeable and shared.
Precisely. And that structure is designed to inherently lower risks and costs compared to traditional systems.
How does that work practically? If it's distributed, where does this ledger actually live?
So this is where it really differs from, say, your company's database, right? That usually sits on a central server controlled by the company. With blockchain, the information, the blocks of data, are copied and spread across many computers in a network.
Ah, so no single point of control.
Exactly. No one person or entity owns the whole system. But anyone who's part of that network can use it, can help operate it, can hold a copy of the ledger.
So if one computer goes offline, it doesn't matter so much.
Not for the network's integrity, no. The data isn't just in one place. It's on potentially thousands of computers. This distribution makes it incredibly difficult for anyone to tamper with the record or, bring the whole system down. It's very resilient.
So the security isn't just about fancy code. It's built into the very structure, the way it's spread out.
That's a huge part of it, yes.
Yeah.
It's a peer-to-peer setup. The network manages itself decentrally without needing that central referee.
So let me make sure I've got this. Everyone participating has their own constantly updated copy of the same ledger.
Synchronized.
They add new information, new transactions, and that gets automatically copied out to everyone else almost instantly.
That's the idea. Peer-to-peer replication keeps everyone on the same page. You're both contributing and subscribing to the shared information stream.
Okay. That distributed nature is definitely a key difference. What other features really make blockchain? Blockchain. What sets it apart?
The sources highlight 4 main things usually. First, what we've touched on. The single source of truth. One shared ledger means everyone looks at the same data to confirm things. No arguments about whose record is right.
Okay, one version of the truth.
Second, consensus. This is crucial. Before a new transaction gets added, a majority of the participants in the network have to computationally agree that it's valid according to the rules.
So it's not just one person saying yes, it's the network collectively agreeing.
Exactly. It's a validation mechanism that prevents dodgy or incorrect data getting onto the chain. Third is origin, or sometimes called provenance. because every transaction links back to the one before it. You can trace an asset or piece of data all the way back. You see its entire history, who owned it when.
Like a permanent audit trail.
A very transparent one, yes. And finally, integrity. This is the immutability part. Once a transaction is recorded and validated, it's basically locked in. You can't delete it or secretly change it.
What if there's a mistake, like a genuine error?
Good question. You can't alter the pass block. Instead, you have to add a new transaction that corrects or reverses the error. And importantly, both the original transaction with the error and the correcting transaction are visible to everyone on the ledger.
So you see the error and the fix, nothing gets hidden.
Right. It preserves the history, warts and all, you could say, and that transparency builds accountability.
Okay, so single source, consensus, origin, and integrity, those really do seem to shape what it is.
They work together to create that secure, transparent, and resilient system.
Let's dig into that security aspect a bit more. That integrity and immutability, how does it technically achieve that? What stops someone from just hacking in and changing a past record?
Well, it's layered. The sources talk about three main elements working together. First is the digital fingerprint, technically called a hash. Before a block of data gets added to the chain, it's run through an algorithm that creates a unique code, the hash. It's like a fingerprint for the data in that specific block.
Okay, unique to the contents.
Yes, but it also includes the hash, the fingerprint, of the previous block in the chain. So each block is cryptographically linked to the one before it, forming the chain.
Right, creating a dependency.
Exactly. Now, if someone tries to tamper with the data in an old block, even changing a single comma, the hash for that block changes completely.
And because the next block contains the original hash?
The link breaks. The chain doesn't match up anymore, and the network immediately sees that block and all subsequent blocks as invalid. Tampering becomes incredibly obvious.
Okay, that makes sense. The chain structure itself reveals tampering. What's the next layer?
Often it's something called proof of work. This is basically a computational puzzle that computers on the network, miners in Bitcoin's case, have to solve to validate transactions and earn the right to add the next block to the chain.
A puzzle. Why?
It's intentionally designed to be difficult and time-consuming. It might take several minutes for the network to find the solution and add a new block. This isn't inefficiency, it's a security measure.
How does slowing things down help security?
Imagine you wanted to tamper with block 100. You'd have to change the data, recalculate its hash, and redo the difficult proof of work for block 100. But because you changed block 100's hash, you've invalidated block 101, which contained the old hash. So now you have to redo the proof of work for block 101 too, and then block 102 and so on for potentially thousands or millions of blocks that came after it.
Wow, okay, you'd have to essentially rebuild the entire chain from that point forward.
Precisely. It would require an absolutely enormous amount of computing power, far more than any single entity is likely to have, and it would take a huge amount of time. The rest of the network, running honestly, would race ahead, making the tampered chain obsolete. It's computationally infeasible to cheat like that.
Got it. The workload makes retroactive changes practically impossible. And the third element.
That ties back to the distributed peer-to-peer network we discussed earlier. Remember, everyone has a copy of the chain. When a new block is proposed, after the proof of work is solved, every independent node, every computer participant checks it. They verify it follows the rules, that the transactions are valid, that the hash links correctly. Only then do they add it to their own copy of the ledger.
So it's not just one server accepting the block, it's thousands of independent checks.
Potentially, yes. To corrupt the chain, you wouldn't just need massive computing power to redo the work. You'd somehow need to convince a majority of these independent, geographically dispersed nodes to all accept your fake block at the same time.
Which sounds unlikely.
Extremely unlikely, given the transparency and independent verification happening constantly. Colluding on that scale without detection is considered practically impossible.
Okay, so it's the crypto linking, the computational difficulty, and the distributed verification all working together. That paints a clearer picture of the security.
It's a defense in depth approach.
Right. Now, let's look ahead a bit. We know it started with Bitcoin, but the sources, they talk about applications way beyond currency. What kind of things are we seeing or expecting?
Oh, the potential is really broad. Things like smart contracts get mentioned a lot. These are basically self-executing contracts where the terms are written into code on the blockchain.
Like if this happens, then automatically do that.
Exactly. Think about supply chain management. A contract could automatically release payment to a supplier once a shipment's arrival is confirmed on the blockchain via an IoT sensor, for example. No manual processing needed.
That could streamline things massively.
Huge potential there. Other areas mentioned include things like digital advertising, verifying ad views perhaps, or managing data from the billions of devices in the Internet of Things securely, even digital identity management.
And governments are looking at this too. You mentioned Estonia earlier.
Yes, Estonia is often held up as a pioneer. They've apparently been testing blockchain for, over a decade. And they now use it in various government services, securing health records, legislative data, banking registries. They saw the security and integrity benefits early on.
Interesting. Is that kind of adoption widespread?
It varies a lot based on the sources. Some countries are definitely more advanced or more open to experimenting than others. And there's an important distinction that comes up. Governments might be quite positive about the underlying blockchain technology, the secure database aspect, but have very different, often cautious views on cryptocurrency specifically.
Separating the tech from one particular application of it.
Precisely. So you see regulators globally kind of grappling with this. They're trying to create frameworks that manage the risks, especially around crypto, but without stifling the innovation potential of the core blockchain technology itself, finding that balance.
Okay, that makes sense. Let's bring it back home for the listener. Imagine they're thinking about this strategically, maybe for their business, like one of the examples in the material. How could this actually solve a problem?
Well, a common scenario discussed is, say, an organization struggling with data security issues. Maybe they've had breaches, or customers complain they can't easily access their own records, or there's just a general lack of trust because processes aren't transparent.
Leading to reputational damage, maybe?
Exactly. In that kind of situation, proposing a shift to blockchain for managing certain sensitive data could be a really strong, justifiable move. Let's use that medical records example again, as it's quite clear. Implementing blockchain could mean that a patient's historical records become fundamentally tamper-proof. They'd be secure, accessible only to the patient and their designated doctors or clinicians.
So the patient gets transparency, they can see their history.
Correct. Full access to view their own records anytime.
Yeah.
But crucially, they cannot change anything in the past. And they certainly can't see anyone else's records.
And the doctors.
Authorized medical professionals could add new information, a new diagnosis, test results, consultation notes. That gets added as a new block. But even they couldn't go back and alter or delete previous entries.
It creates this unbreakable, time-stamped history.
Exactly. A permanent, highly secure, auditable trail that builds trust for everyone involved.
That kind of built-in integrity really is tough to achieve with traditional systems where someone, somewhere, usually has the admin rights to change things.
That's one of the core value propositions.
Okay, so wrapping this up, this deep dive based on your material really shows the power of blockchain. It's this immutable, decentralized ledger idea secured through these clever layers of cryptography, proof of work, and network consensus. It really does feel like something potentially disruptive.
And once you grasp those core ideas, the immutability, the distribution, the consensus, you start to see why it's being explored in so many different fields, far beyond just its origins in finance.
Right. The potential applications seem vast, even if the adoption is still evolving and facing regulatory hurdles in some areas.
Absolutely.
So maybe a final thought for you, the listener, to take away from this. Considering these features, the security, the transparency, the way it shifts control away from a central point, how might this technology challenge our basic assumptions about who owns and controls information and how trust is built, not just in big sectors like finance or healthcare, but maybe in other aspects of our lives too? Something to think about.